Does our sun have an evil twin? A star named Nemesis orbiting the distant reaches of our solar system? And every 26 million years, does it fling comets from the Oort cloud toward Earth?
Sometimes they get tossed out, other times they orbit harmlessly until they evaporate and go away. If you have comets rattling through the inner solar system, then in a sense, all bets are off.
Scientist Richard Muller not only theorizes that this periodic mayhem is caused by a deadly companion star to the sun, he believes he knows precisely what kind of star it is: a red dwarf.
That there is a star orbiting the sun in a 26 million year period, that was my idea. Let's assume the star is a red dwarf star. Why red dwarf? Because that's the most populous star in the galaxy.
A red dwarf is a tiny star that weighs in with a mass less than 1/10 of our sun. But as astronomer Greg Laughlin demonstrates, it can have the effect of a 9-pound bowling ball tossed into the arms of a juggler playing with fire.
All by itself, the Oort cloud is a pretty boring place, and so we're going to have to up the ante a little bit. So these are going to represent the comets in the Oort cloud.
You ready?
I think I'm going to step back a little bit. So Josh has got them all going nicely, just like the comets orbiting in the Oort cloud. So let's see what would happen if I took this red dwarf and tossed it into the solar system. Josh, are you ready for the red dwarf?
Yeah.
Here we go.
Oh.
So as you can see, the red dwarf coming through the solar system has really changed the orbits of the comets. Notice that 2 of these comets actually crashed onto the Earth. That's not unlike what happens when a giant impact occurs and we get one of these mass extinctions.
For many people, the idea that Earth has been the victim of a series of impacts caused by an orbiting Death Star seems unlikely. After all, when we look at the sky, we only see one sun. But in fact, the majority of stars come in pairs.
Probably something like 60–70% of stars may indeed be binary or have even higher numbers of stars in the system.
According to Richard Muller's Nemesis Hypothesis, our sun is part of such a binary star system.
It all works. All you have to do is hypothesize that the sun, like 2/3 of all the other stars in the galaxy, has a companion. This one with a 26 million year period, and there you have it.
But if so, why don't we see the sun's twin in the sky? According to Muller, the reason is simple. Nemesis is an extremely dim red dwarf.
When I first came up with the Nemesis theory, the issue was, well, wait a minute, how come nobody found it? And that was pretty obvious. It has to be hard to find.
By definition, a red dwarf barely glows at all.
It would be the closest star to our sun, and we wouldn't even know it. Now, why is that? The way we discover nearby stars is either because they're very bright, and a red dwarf star is not very bright, or because the sun is moving past it. This star is moving with us. Yes, it's orbiting us, but that orbit is very slow, 26 million years. So it would be moving with us. It would just be at a fixed position in the sky and wouldn't move.
In other words, when viewed from Earth, most nearby objects are shifting over time. But Nemesis is sitting still. That something so relatively near to Earth can be so obscure is what Frank Jankowski of Mobile, Alabama, wants to ask the universe. Why can scientists observe objects in space that are millions of light years away, yet have difficulty spotting objects at the edge of our own solar system?
That's an interesting question, Frank. The objects that are millions of light years away that astronomers can see are powerful and luminous. They produce a lot of energy on their own, like an exploding star. But an object near the edge of our solar system might be small, and it reflects only a little bit of sunlight, so we can't see it at visible wavelengths.